So we're going to talk about finding area between two curves. See, here's the thing. When you write this, oh, that didn't work. Yeah. When you write this, how is that related to area? In relation to the x-axis, right? You have your x-axis and you have your y-axis. And so Matt says, well, okay, if I have a curve, I'm looking at the x-axis, and I look at A and B, wherever they are, right? And what area does this give me? This gives me the area between the curve f of x and the x-axis, right? So we're used to that. But see, a lot of times what happens, get out another color, is you'll have two curves. So call this one g of x. And what I'm interested in often is the area in between these two curves. Now, why am I interested in the area between those two curves? I'll tell you what, the best reasons I've seen are in your book. I teach the science majors this stuff all the time, and we have our reasons. But you guys have better reasons, I think, of why we're interested in these areas. And so I'll get to that. But say I want to know the area of that blue squibble right there. Okay? We're going to pause. We're going to let everybody talk to somebody, because you guys have been very quiet for a long time. And I want you to come up with a game plan of how you're going to find it. And Nick is at a huge advantage because he's talking to Matt, who's seen this before. But I don't know if anyone else has, so we'll see what happens. You guys are quick. What's that? You guys are quick, right? I mean, I heard a lot of people coming up with the right answer. Some people read it. Some people figured it out. Well, my point is, do we all understand it? Here's the deal. Suppose I did the integral from a to b of g of x. What's that give you? That gives you this area in here that's red. Right? So if you want the area in blue, take the area in black and subtract the area in red. Right? So do this integral minus that integral. That's the idea. Two separate problems, subtract them. Of course, you don't have to do it that way. You can make it, because notice, you know, when I'm integrating f and I'm integrating g and subtracting, I guess the quick way to do it is to write it as one integral from a to b. And what is it I want to integrate? F of x minus g of x. That'll give you the same thing. Okay? Does that make sense to people? Because this is equal to these two. We do it all the time where we have something like this and we split it up into two integrals. Well, now, if you want to, you could put them back together also for adding or subtracting. I think this formula is okay. I think much more important is the ideas that you guys are coming up with here. Because that's what we really want, or how you tackle different problems. You're developing ideas to tackle them. So here's a problem. I want to go after it and see if we can come up with this. Find the area enclosed by the graphs of these functions. Now you might not know what I'm even talking about when I write that down. Although you could probably graph these functions. Even by hand you probably could. What's the graph of this function going to look like? Parabola opening which way? So that's a parabola opening upward. What's this? Straight line through what? Through 0, 4, right? So it'll be up here somewhere, 0, 4, because here's the parabola goes through 0, 0. I don't know if you noticed that, but it does. Right? F of 0 is 0. G of 0 is 4. What's the slope of this line? 2, so it goes up, something like that. Maybe a little steeper than that. So when I say find the area enclosed by these graphs, it's a really funny shaped piece I'm looking for here. I'm looking for this, right? And this is f of x, the parabola, and this is g of x, the line, right? So we need a game plan. Well, I guess what I did last time was I integrated from a to b, where a and b are going to be these lines where the curves intersect. That's what you need to find. You need to figure out where do these curves intersect, the curve and the line. Now, how do you do that algebraically? Yeah, we want f of x to equal g of x. We want 2x squared equals 2x plus 4. When you say do it in your calculator, what do you mean? Yes. Yes. Matter of fact, I'll show you how to do that. I mean, because this, what would you have to do? Would you guys know how to solve this? Well, you can factor out the 2. Oops. You could use a quadratic formula. I think this one I designed so you didn't need the formula. Just go back to my math 0950 class and you'd be doing this kind of stuff, huh? Remember that? Ooh. All right, we'll use the calculator. But actually, you can see the answers now. So let's go to the calculator and show you how to do it that way. Okay, so what do we have? My first function, I'll say 2x squared, right? And my second function, I say 2x plus 4. Okay. And if I hit the zoom key, for this example, if you do zoom standard, it shows up real nice. So I'm going to do choice 6 there. There's my curve and my line. And see, I'm trying to find the area right in there. Okay? Is that all right? So, oh yeah, this is what Nick was talking about, is that if you want to find intersections, there's a quick way to do it in the calculator. All right? So what I want to do here is find the intersection. So if I hit second calculate, choice number 5 says intersect. This is real nice. And what I do is I hit enter. And it says, what's the first curve you want to find the intersection for? Well, it's this one. Y equals 2x squared. Y1 is 2x squared, so I'll hit enter. What's the second curve? Y equals 2x plus 4. Enter. Now it says guess. Well, this is kind of weird. What you have to do is you have to basically tell it approximately what the answer is. And sometimes you don't know. So what I do is I use the arrow key. And I'm going to move over to the left until I get pretty close to where they intersect. And it'll start there then and find the intersection that's closest to that. So it says -1, 2. See, if I do it again, I'm going to do it again. Find the intersection. Again, first curve, second curve. But if I make my guess way over here, it'll find that intersection. 2, 8. Okay? So, yeah, I guess a couple ways you could do it. If I did it this way, algebraically, I get the x values, right? X is -1 or x is 2. How do you get the y values? You could plug it into which function? You could plug it into g of x, or plug it in f of x, right? Because that's where they're equal. But if you think about it, I don't know that I even need it. My a here is going to be -1, and my b here is going to be 2. And really, that's all I need. Because to do this problem, find the area, I'm just going to be integrating. So let's do the work in red. How about that? So we're going to integrate from what to what? -1 to 2. And then, if you think about what's happening, oh, okay, so I did it backwards here. See, the way you want to integrate is you want to integrate top minus bottom dx. Your book does that. The authors do that, and I really like that because that makes sense to me. That the top function in this case is g, and the bottom function in this case is f. Do you guys see that? Because we're trying to get the area in black. So if I integrate 2x plus 4, that's going to give me everything. And then if I want to subtract out the red, I subtract the 2x squared. So this is the integral you want to do. Okay? 2x plus 4 minus 2x squared. I'm going to give you guys a few minutes to work that out. I think this one works out really nice, right? So you go from -1 to 2, like this. So if I put in -1, oh no, I'll put in the 2 first. I'm sorry. 2 squared plus 4 times 2 minus 2/3 of 2 cubed. Okay. And then subtract what you get when you put in -1. Okay. 4 and 8 is 12 minus 16/3. And then let's see, -4, -3, so plus 3. And then that becomes minus 2/3. So I get 15 minus 18/3, which is 6. I got 9. Anyone else get 9? All right. So my arithmetic's okay. Suppose I know the marginal revenue and the marginal cost. So I have 2 questions, I guess. Number 1 is, how do we maximize profit? And number 2 is, what will the profit be? That's my question. Is this something you guys studied in other classes? So Norman says yes, Mike says yes. So what did you guys learn about how this works? Yeah, Norman?
When MR equals MC, that's like the maximum profit.
So you're saying, here's marginal revenue, MR, and here's MC. And you're saying, when they're equal, this will maximize profit. Where'd you learn that? They told you that in econ?
Yeah.
They tell you what?
Well, like, because when they like hit each other, just
I don't think that's a profit maximizing, isn't it? It will only produce when marginal revenue is equal to marginal cost.
because it'll give you this profit.
I don't think it's necessarily maximum profit, is it?
So you don't think it's maximum profit, but Norm was talking. I wanted to know, did they tell you why?
I think so.
It'll only produce from that equal balance.
Go ahead. I'm sorry.
Because like otherwise, if they like increase the cost, the revenue's gonna go down. Like, you know, if they're like selling it too low, they're not being efficient.
Okay.
Because marginal is the change.
Marginal is change, and we understand that too, yeah.
So that doesn't mean, it means you're going to produce as long as the change in revenue is greater than the change in cost.
Then once it's
Or
like,
equal.
it would be like the change in cost is more than the change in revenue.
So you're not going to produce if your costs are going up and your revenue is going down or equal.
Oh,
So
yeah. Okay. That's how I explained it. Because like until it hits that, you're making revenue. But then once you like go past that point, your costs are greater, so your revenue
Doesn't
goes
have
up.
to do with the limits too. Like if you get past
Law of diminishing returns. It's just interesting for me to hear you guys are totally getting into this conversation. I mean, you've seen this before, and different people have explained it different ways, okay? Now, I told you going into the lecture, this is not my area of expertise, right? But maybe what I can do is give you another way to put your foot down using mathematics and saying, oh, I get it. Because I understand this problem, but I'll show you how, okay? What are we trying to do? Maximize what? Profit. I'm going to make up a new function for profit, P of x. Now, how do you get P of x? How do we get profit? Revenue minus, right? So it equals R of x minus what? C of x. Okay. Now I'm going to go back to Calc 1. To maximize P of x, to find the maximum value of P of x, what do we do? I don't want to think about this at all other than just as a math class. You know, set what equal to 0? Well, you could set the function equal to 0. I guess your profit might be 0 somewhere. But that's not what I'm looking for. If I'm thinking of profit as having a maximum somewhere, how do I find it? This was kind of the whole point of Calc 1. Find the first derivative. So we're going to find, critical points. How do you find critical points? You find P prime of x and set it equal to what? To 0. How many remember this? Sure, of course you do. You couldn't be in this class if you didn't remember that. Find P prime of x. Okay, I'm going to do that. P prime of x equals what? How do you take the derivative of r minus c? Well, you need r prime of x, right? Minus what? C prime of x. Okay, and now what do we do? Set this equal to 0. So this is what we want. R prime of x minus C of prime of x equals 0. Well, if that's what you want, what does that mean? R prime of x equals what? To me, that's an easy explanation of why this will maximize profit. It only makes sense if you understand your applied Calc 1. But I think you guys in this class do, and I think does that seem clear? It's because you're setting the profit derivative equal to 0. So that means setting revenue derivative and cost derivative equal, the two marginal functions equal. Okay, fine. Now, here's a problem where we're going to try and do this. Okay? So an oil company's revenue rate in millions of dollars per year is given by this. By the way, this is slightly different. Those other functions I had were functions of x, right? Those were marginal revenue, where like you have one extra unit produced. This isn't. This is a problem where I found where I have it in terms of t, time. But the ideas are the same. We're going to set r prime equal to c prime to figure out what's happening. Because again, I'm trying to maximize profit. The same argument that I just gave you would go through here. Just changing the units to time instead of units produced. So I have r prime of t and c prime of t are given here. I know how much it costs per year, and I know how much I'm bringing in per year. Actually, how I know that, I have no idea. The marketing guru gave that information to me. Okay. Question is, if I know this stuff, how long should the company operate? That's the question. Anyone know someone in the oil business? Well, he works for Exxon. don't know if that counts. He's been doing it ever since college. He has a really nice career. He's traveling all over the world. He's going to go into Calgary next. He was in Spain for 3 years with his family. But they, they drill these oil wells, but there comes a point, you guys mentioned the law of diminishing returns. You don't want to keep operating, trying to squeeze out that oil forever because it's just not worth it after a while, right? So here's an example. How long should this company operate? Okay, so what do? We want to maximize profit, right? So what do? Well, we just learned from the last slide we should set what? R prime equal to C prime. Okay? So let's do that. A little bit of math here. 9 minus t to the 1/3 equals 1 plus 3t to the 1/3. This is a made for a math classroom example, by the way. You could tell because what happens? You subtract 1, you get 8 equals 4 t to the 1/3. Is that okay? What I just did? So then what do I get? T to the 1/3 equals 2. So t equals 8. Cube both sides. All right? So how long should the company operate? 8 years. What will be the expected profit? That question not so easy.
You have to integrate both sides. Plug it in.
So that's an interesting thing. Your idea is we need revenue minus cost, and what I'm given is R prime. So I could integrate this, subtract. I could integrate this, right? Integrate this, and then subtract, and you get it, and you're right. Okay? What do you think our book does with this problem? Let's make it one integral. What you're really doing, if I pull out the calculator here and try and work it out this way, let me go to the y equals screen. Here. By the way, what's going to be higher, revenue or costs? We hope the revenue's higher, right? Sure hope so. So let's see. I'm going to put in this into y2. So r prime of t, so let's see, is going to be 9 minus, I guess I'll have to put x caret, open parentheses, 1 divided by 3. Oops. 3. So that's going to be r prime of t. And then c prime of t I'll put up there. And let me just not graph this guy because that was confusing last time. So c prime of t would be 1 plus 3x caret 1/3 again. Okay, so I could graph these two functions. Okay, so there's a graph. And what you're doing in this problem, the first one here is the revenue function. No, it's the derivative of the revenue. The next one is the derivative of the cost, right? So what we're really doing here is we're going to subtract, we're going to find the area between these two curves. Okay? Yeah, so let me zoom in just a tiny bit, or let me change the window a tiny bit. I want to make x min 0. I'm going to graph it. See that function? What function is that I just graphed? That's c prime of t. No, is that right?
Yeah, it is.
Yeah, that's c prime of t. And this guy here is r prime of t. Okay? So what do I want to do? I want to do the integral of which way? R prime minus C prime? Yeah, R prime minus C prime. We always want top minus bottom. That's why I had to pay attention to which one's which. So here, the next slide, we can work it out. We're going to integrate R prime of t minus C prime of t dt. Oh, from what to what? From 0 to 8. See, I didn't know the 8 right away. I had to figure that out. First, I have to figure out how long should we have this company run. Now I'll figure out the profit. So here it is. And again, what Mike said is you could do these separately, and he's right. You could do them separately. But I'll do them together here. So what do I get? Let's see. Integrate from 0 to 8. I guess I get 9 minus t to the 1/3 minus, and then in parentheses I'll put the 1 plus 3t to the 1/3 dt. So this actually works out kind of nice because you can simplify what's in here. So what we're integrating really is 8 minus 4t to the 1/3 dt. Is that okay? So this is going to be integral from 0. Oh no, let's integrate. We have it simplified. Let's integrate. So we'll integrate 8. What do we get? 8t, because I'm doing dt. And here, I'm going to get t to the 4/3 power. But then what do I have to bring out front? Yeah, because it's 3/4, and I had a 4 there, so I'll just put minus 3. And we're going from 0 to 8. So this is going to be 8 times 8 minus 3 times 8 to the 4/3 power. And now, when you put in the zeros, you don't get anything. Right? Those all zero out. So let's see, I get 64 minus, you guys know how to simplify this? I guess I would take the cube root of 8, right? Do the root before the power. So it's just 2 to the 4th. So that's 16. So it's 64 minus 48 is 12. Okay, so what's that mean? It's too bad I can't subtract, because it was so good up to there. So profit is what? 16 million. Now, that's almost right. There's one major flaw with doing this, and the book doesn't mention this. I said the profit's $16 million. That's not quite right, because think about it if you did it the way Mike suggested, which might be an advantage to it. If you just integrated these guys separately, right? See, what would happen is, when you integrate this guy, for instance, you'd get t plus, okay, so let's see, I would need 3/4, so I get 9/4 t to the 4/3, right? Remember how we get a plus c? Your startup costs? See, if all you know is this, you don't know the startup costs, and I think that could tap into the profit a little bit. But ignoring startup costs, yeah, the profit's 16 million. So that's one thing to keep in mind, I guess, with this problem. I better do this. All right, so let's just finish with this example, and then we'll take our break number 2 today. Find the area enclosed by the graphs of these functions. So I really should just let you guys work on this. What's the first step? Graph them, or, yeah, set them equal to each other, right? Because we want to find the points of intersection. Yeah, we really want to graph them. So we want to graph and find points of intersection. So I guess I'll find points of intersection. If you want to graph it, go ahead. This one is another made for the math class example. Works out real nice. Factor out your x. And then you get that. Okay, so where do these things intersect? At 0, at -2, and at +1. Right? So when we draw this graph, I could draw x cubed. Do you guys know what that looks like? Kind of like this, right? Right? Now the other one's a parabola, opening downward. I got to think more about that one here. But it says that we're going to get intersections at 0, well, 0, 0, at -2, -8, and at +1, I guess it would be +1. Right? So, I don't see it. I'm going to put this on the graphing calculator. We'll take a look at it. So I typed in the functions. I'm going to graph them now. Let me just use Zoom Standard. Okay. Hard to see. But I guess I have an idea of what's happening now. It looks like the other curve, the parabola, I'll draw in black. The parabola g of x comes up a little bit steeper, goes through here, somehow goes through both of these. Have to see it again up close. Here, I'm going to zoom in because I'm having trouble seeing exactly what's going on right there. Okay? So I'm going to go back to the calculator, and I'm going to zoom in. Choice 2. Oh, I zoomed in 5 times. I didn't want to do that. We'll try again. Zoom out. Okay. Now we'll zoom in one more time. I'm graphing the cubic, and then I'm graphing the parabola. Okay, so now you can see what happened. This is a nice picture of it. When I'm between -2 and 0, which curve is on top, the cubic or the parabola? The cubic is on top over here. Once I get to this side, what's on top? The parabola. Do you guys see that? That's an issue. Why? You have to split it up, right? Yeah, because top minus bottom is our formula, but that changes. Top minus bottom is our formula. But notice that changed in this problem. Yeah, so if I'm going to do this one, here's what I need to do. I guess what I would do is this. Integrate from, say, -2 to 0. So top minus bottom there, we said this is not drawn right. The cubic is on top of the parabola. So we would do f of x minus g of x dx. Okay? Plus, and now what you do is you integrate from here to here, from 0 to 1. And what's it going to be? G minus f, right? dx. Does that make sense to people?
Is that negative area going to show up as a negative?
That's a good question. See, here's the other issue. You guys know what he means by negative area? What's he mean? Because, yeah, over on this side, aren't things below the x-axis? Okay? Now, it's very interesting what happens here. It turns out it doesn't matter. We're going to be fine when you have two curves and you're finding the area between. Because you think about how would you do it? Here, let's draw the picture the right way. If you look at just that side over there, we have the cubic on top from -2, -8 up to 0, 0. The cubic is on top of the parabola for that portion there. So here's the parabola, right? And the cubic is on top. Now, if you think about how would I actually find the area? Well, what you might do is you say, well, here's the x-axis. You might think, okay, I'll find this area first, the black. And then I'll subtract off this green in here. Now, how do you find the area of the green? Well, you integrate the cubic. How do you find the area of the black? You integrate what? You see what I'm doing? How do I find the area of this black? You integrate the parabola, -x squared plus 2x. Now, then I say subtract them. But here's the thing. The green area, is it going to be a positive number or a negative number when I do that integral? Negative. The black is also going to be a negative. And so negative, negative makes a positive. So it's almost like switching them around, doing top minus bottom, and just forgetting about the signs. So the point is, top minus bottom takes care of it. If you do top minus bottom, you're fine. It'll give you the area, positive area, and it'll do it right. So the only thing you got to do is make sure that if it switches, that you account for it like you do here. And this one, I don't have it worked out, but if you work it out, it ends up being a nice answer. Okay. I kind of want to stop and take your other 5-minute break. I know Judd has to go anyways.